Hello and welcome back. In this video we will start section 1.1. So to begin learning about trigonometry, we'll need to all be speaking the same language. This section is mostly about terminology and the words that we'll use to describe things. So to begin with, some very simple language. If you have 2 points, A and B, I've labeled these here, there's one straight line that goes through them. You'll just have to pretend that this is straight, and we call this a line. A line will go forever in both directions, and if I want to specify which line it is, I can tell you what 2 points it goes between. So this is going to be the line AB. The line BA is going to be the same thing. It doesn't matter the direction. Here, if we cut the line off at those 2 points, we will call this a line segment. And again, this will be the line segment AB. And here, maybe the direction matters. Maybe we want to start at A and end at B. So BA would be the same line segment, but in our head we'd be thinking we'd be going the opposite direction. The only place where the direction really matters is here. This is going to be a ray. So it's going to start at A and continue on forever, passing through B. This is what's called a ray. So it's going to be ray AB. We kind of think of this as a ray of light. If we have a flashlight at A and it's pointing at B, that light is just going to continue on in the same direction forever. So this is called a ray AB. And A here is called an endpoint. Up here, the line segment AB has 2 endpoints, A and B. This only has 1. Now, with trigonometry, one of the most important things that we'll be talking about are angles. And angles are going to be when 2 rays, or 2 line segments, sort of connect at a common endpoint. So here, I have the ray CA and the ray CB, and they connect here. So the angle between them is just going to be somehow how far apart, or the sort of spread between these 2 lines. And the angle is always measured from what's called the initial side to the terminal side. So let's, for instance, say that this is going to be the initial side in this instance, and let's say that this is the terminal side. We could switch these around and talk about the angle going in the other direction. So going from the initial to the terminal side, maybe we would have the angle here. And what we'll notice is that I could draw the angle going this way, or I could draw the angle from the initial, from the initial side going the opposite direction. So which one of these is the angle that we're talking about? They are both the angles that we're talking about. We just have to be a little bit careful. The angle going in the clockwise direction, so following around this way, is going to be a negative angle. The angle coming from the initial side to the terminal side going counterclockwise is the positive angle. So there will be multiple angles that will, there will be multiple numbers that will correspond to the same angle. We'll describe them with different numbers, but ones that are going counterclockwise are always going to be positive. Ones that are going clockwise are going to be negative. This is just a choice that mathematicians have made at some point. There's no reason why this should be the positive direction and this is the negative direction. A little bit more information. The way that we're going to measure an angle is primarily going to be in degrees to start with, and a full rotation. So if I start at this line and I go all the way around and I come back to that line, this is going to be 360 degrees. So 1 degree is going to be 1/360th of the way toward a full rotation. So we have to go 360 parts until we get back to the original starting point. Just as an aside, the reason that 360 is chosen is because we can divide it up evenly pretty well. So 360 is even, so I can cut it in half. So half of 360 would be 180. We can split 360 into thirds, which is going to be 120. We can split it into fourths, into fifths, into sixths, not into sevenths, unfortunately, but into eighths, ninths, and tenths. And 360 is, in fact, the smallest number that's divisible by 2, 3, 4, 5, 6, 8, 9, and 10. So when we're talking about these angles, some of them will have some names so that we can identify them a little bit easier. So angles between 0 and 90 degrees are called acute. These are the angles. So 90 degrees is going to be exactly 1/4 of 360. So it's going to be exactly 1/4 of the way around. This is called a right angle. So if our initial side is pointing straight to the right, a 90-degree angle, the terminal side will be pointing straight up. And we normally use a square angle sign, so it looks something like this. And we'll use a sort of this square angled sign, this one with a sharp corner, to say I know that this is a 90-degree angle. An acute angle is going to be one that's essentially smaller than that, so it's going to be somewhere in between. Angles that are bigger than 90, but are still between 90 and 180, are going to be called obtuse. The special thing about 180 specifically is that 180 is exactly 1/2 of 360, as in it's going to be half of a rotation. So if my terminal side is pointing straight off to the right, and I flip this over and my terminal side is pointing straight to the left, I've made exactly 1/2 of a rotation, and that angle is going to be half of 360, which is 180. So obtuse angles are the ones that are between being a straight angle and being a right angle. We'll quite often use the letter theta, the Greek letter theta, to represent an angle. We can use whatever letter we like. If it's unknown and we don't know what the angle is, maybe we'll call it x, maybe we'll call it y, but quite often theta is what we'll use. And two words that we'll use to describe angles are complementary and supplementary. And they're quite nice. Complementary angles are angles who add up to 90, and supplementary angles are angles that add up to 180. So for example, what are the complementary and supplementary angles to 45 degrees? So we can kind of think, okay, so the complementary angle to 45 degrees is whatever angle I would add to 45 degrees to get 90. So let's say that my angle is theta, and it's going to be complementary to 45 degrees. That means that if I take theta and I add 45 to it, I should get 90. So then here, I can solve for theta by subtracting 45 from both sides, and we'll get that theta is also 45 degrees. So if I draw a picture of what's going on, if I take a 45-degree angle, and I have another 45-degree angle, and I put them together, I should get a right angle. That's all complementary means. When I put those angles together, I should get a 90-degree angle. Supplementary, slightly different, that's 180 degrees. So again, let's say that I'm trying to find the supplementary angle to 45 degrees. That means that whatever angle it is, if I add 45 degrees to it, if I could add 45 degrees to it, I should get 180 degrees. And again, I can just subtract 45 from both sides. I'll get 135 degrees. So 180, remember, is a very special angle, and that is just going to be a straight angle. So 45 degrees and 135 degrees, it'll be something like this. So if my first angle is 45, and my second angle is 135 degrees, that should form a straight line because it's 180 degrees. So complementary and supplementary angles are quite nice. They add up to make right angles and straight angles. So one thing that we can also do is throw in some variables in here. So here I have two angles. One angle is x and the other angle is 4x. And we can see that we've put these together. And again, this sort of squarish angle sign means we have a right angle here. So if I want to know what are the angles here, I know that they add up to 90 degrees. So I know that if I add this first angle, which is 4x, plus the second angle, which is x, I should get 90 degrees. I know I should get this right angle right here. So when I add 4x and x, I will get 5x. And then again, dividing both sides by 5, I will get x is equal to 18 degrees. So here, I know that x here, well, this is going to be an 18 degree angle. And up here, this is going to be 4 times x. So if I take 18 times 4, do this math really quick, I get 72. So this angle up here is going to be a 72 degree angle. So I knew all of this because I knew these angles in terms of x, and I know that they add up to 90. Over here we have a similar situation. We have 3x and 7x. So when I look at this, I notice that this is a straight line. So the angle here is going to be 180. So I know that if I add 3x degrees and 7x degrees, I should get 180 degrees. So 3x plus 7x is going to be 180. I add these together, I get 10x is equal to 180. So x is going to be equal to 18 after I divide both sides by 10. So all that comes now is, okay, so that's x, so I need 3x and 7x. So 3 times x, 18 times 3, 8 times 3 is 24, so this is going to be 54. And if I take 18 times 7, I'll get 56. Oops. Carry the 5 on 126. So this angle over here is going to be 126 degrees, and this angle over here is going to be 54 degrees. Now, we've done all this work. We can actually go back through and check really quick. Let's check to make sure if I add 126 and 54, I actually do get 180 degrees, which is the angle of the straight line. So I have done my math correct. And I think I will stop here and continue this section in the next video.